Hello, Algebra 1. Today we're going to be looking at quadratic functions in vertex form. So there's a Desmos activity that you should be clicking on. There's a link in the post. And so I want you to work through that activity. Anytime you get stuck, feel free to press play because I'm going to be working through the activity itself. But try it on your own and see how much of it you can do, okay? So at this point, you should press pause. So let's look at this first slide here. We say we have that quadratic functions in vertex form are given by f of x equals a times the quantity of x minus h squared. And we're going to be looking at what a, h, and k, how they'll affect the graph of these parabolas. And so let's play around with this. So one of the things I hope you notice is that when a is negative, your graph is concave down. You notice how when a becomes positive, it becomes concave up, right? And do you notice how the greater the a value is, right? The greater the absolute value of it is, the narrower the graph becomes. Look at what happens when you look at graph between 0 and 1. It gets wider, right? From 1, as I get closer to 0, it gets wider and wider and wider. The h value, hopefully you notice that when you move the h value, that's what affects the graph horizontally, right? If h is 3, for example, my graph is shifted to the right 3 units. If I move h at -2, you notice my vertex is situated at x equals -2. If you look at the k value, when k is 4, you notice how my graph, or when k is 5, excuse me, the graph got shifted up 5 units, right? Do you notice that the y-coordinate of the vertex is 5? When k is -2, what do you notice about the y-coordinate of the vertex there? Right, and hopefully you notice that was just the k value. And so hopefully you're able to make some observations here. Now in this first case, they want us to know how to type functions. And so the way you would type y equals x squared would be you'd start with y equals, and then here you can just press x and then the exponent button. And that would be one way you can do that. So in this case, if you notice, my graph is shifted to the left and to the right. And so what that tells me is that I'm thinking of the vertex form where I'm going to make it so that it's the h value, right? That's going to be changing. So looking at this graph here, the red graph is at y equals x squared. If you look at the blue dots, you notice that the graph got shifted to the left 5 units. And so what that tells me is that I'm going to either have x minus 5 or x plus 5. And because it got shifted, because the vertex is at -5, I'm going to write x minus -5. And you want to make sure you square that. And if you notice, you get that answer. So really, I could have just written this as x plus 5 quantity squared. Looking at the green parabola, you notice how it got shifted to the right 3 units. And so because my x coordinate of the vertex is at +3, I want to write x minus +3. And again, you want to make sure you square that. If you check your work, that does work out nicely. So those are your horizontal shifts. Here it says Mr. Kim thinks the equation y equals x minus 3 quantity squared will match the blue graph. Mr. Harrington thinks it will match the red graph, who is correct. Now, hopefully you chose Mrs. Harrington to be the correct person because x minus 3 quantity squared means you're really shifting it to the right 3 units, right? Because h is really 3. And h is the x coordinate of your vertex. For this one, if you notice, the parabola is now above and below y equals x squared. So we have what we call a vertical shift, right, or vertical translation. And so in this case, you would first start by writing x squared. And because it's a vertical shift, I know I'm going to be adding something at the end. In this case, because it looks like the vertex moved up 3 units, it'd be +3. If I check my work, it works out nicely. And if you look at the green one, it looks like it got shifted down 5 units, right? So because it got shifted down 5 units, I want to put y equals x squared minus 5. And if I check my work, it works out nicely. Now for this one, this is without looking at the graphs, predict how the graph y equals x squared plus 8 will compare to the graph of y equals x squared. So hopefully you recognize that that plus 8 will be a vertical shift. Right? That means it's going to be moved up 8 units. Okay? Find the equation of the parabola shown on the left. Try typing your answer in this form. So look at where the vertex is at, right? The vertex is at 4, -1. So for now, what I'm going to do is I'm going to leave a as 1 for now. So because my graph got shifted right 4 units, I know I need x minus 4 squared. And then because it got moved down 1 unit, I'm going to put a -1. And you notice it matches, and that's my answer. In this case, I have a concave down parabola. So what that tells me is that I'm going to probably need a negative in the front, right? I don't know what the a value can be like. It could be like -2, -3. Now my vertex here is at -3, -5. So because my vertex is at -3, I know this is x minus -3. Which, by the way, is just really just x plus 3 then, right? And then because it got shifted down 5 units, I'll put -5. And it matches very nicely. Now here the equation for the quadratic equation, x plus 4 squared plus 1. The vertex is -4, 1. For the next equation, y equals x minus 6 squared minus 9. The vertex located at 6, -9. The equation for the quadratic function, x plus 3 quantity squared minus 5. Where would the vertex be? Here you would want to say -3, comma, -5. Explain your thinking. Well, I noticed that whenever you're looking at the value next to the x, you always want to take like the opposite value, right? So if it's x plus 3, you think, oh, it's -3. But the value on the outside, it always tells the truth, right? So if I see -5, I think down 5. So anytime I think a horizontal shift, I think opposite. I think almost like a lie. It's a lie. Because you see +3, and you think, okay, 3 right? But no, it's a lie. You always go left 3. But whenever you move something vertically, that's going to be the number at the end, and that always tells the truth, okay? So vertical shifts are truthful. Horizontal shifts, they're liars. That's how I remember that. So what is a vertex here? So when I see x plus 7, I think, okay, that's going to be my horizontal shift, right? The h value moves it horizontally. That's a lie. So I'm going to put -7. And then that +3 at the end, I know that's your vertical shift. That tells the truth. +3, I think up 3 units, right? So it'll be -7, 3. Find the equation here. So now I'm going to start off with the usual, right? Y equals. Now, because it got shifted to the right 5 units, I know this will be x minus 5 squared. And got shifted up 2 units, so it'll be +2. But if you notice here, the graph that they want me to come up with is more narrower. And I know that means that my a value has to be greater than 1. So if I put a 2 there, oh, that doesn't work. If I put a 3 there, okay, that works. Find the equation for the parabola shown in the graph in factored form and vertex form. So in factored form, that's what we did a couple of days ago, right? Here, I know that my a value is going to be negative because it's concave down, so I'm going to put a negative there for now. One of my x-intercepts is at -5. So that tells me I'm going to have x plus 5 as one of my factors. And then another x-intercept at -1. That's going to give me x plus 1. But if you notice, my graph doesn't quite match. It looks like my graph got wider. So I'm going to make this a number between 0 and 1, like 1/2. And that works. Now, when I do the vertex form, I notice that my a value is going to be the same a value. Like, that's not going to change. So -1 divided by 2. And then I notice that my vertex is at -3, 2. So it got shifted to the right 3 units. So this would be x plus 3. And they got shifted up 2. So that'd be +2. And if I check my work, it works out nicely. So that's the end of this Desmos activity. So hopefully you get an idea of vertex form. What we're going to do next is we're going to be looking at some notes. So you should have that blank worksheet with you, this page right here. And let's just carefully work through this. So what we've been working with is something called vertex form. And this is the form y equals a times x minus h squared plus k. So what do you notice what happens when a is greater than 1? We get a vertical stretch. Essentially, your graph is going to look more narrower, right? And when a is between 0 and 1, you get what we call a horizontal stretch. In other words, your graph will look wider. So it'll look maybe more like this. A little bit of exaggeration just so you can see the difference, okay? Now the h value, keep in mind when the h value will be what the horizontal shift, right? So when h is positive, you're going to move to the right. And when h is negative, you move to the left. When k is positive, that's your vertical shift. You're going to move up. And when k is negative, you're going to move down. Okay? And so at this point, what I want you to do is I want you to match the function with the graphs, right? So the graphs are number 1 through 6. I want you to put a number next to the function that you think is depicted by that graph. So I want you to number 1 through 6 next to the function whose graph you think it matches. So press pause, and then when you're ready, press play. So if you do this carefully, you should end up with these as your 6 answers. If you're not sure how you got that, think about what happens when you're doing a horizontal shift. Think a lie. So for example, if I'm looking at this here, I see x minus 2 squared, right? I see that inside the parentheses. I know that's a horizontal shift, and I think horizontal shifts are lies. So when I see minus 2, I think really right 2 units. And so that's why the answer for that should be 4, right? It's a vertex shifted right units, 2 units to the right, right? And that's 2 right there. And things like that, right? So hopefully you can notice those transformations. At this point, I want you to try 1 through 6 again on your own. This time it's a little bit more complicated because now you're going to be dealing with multiple transformations, right? So when you're press pause, and when you're done, press play. So if you did this correctly, the answers that you should get for this one is 6, 2, 5, 1, 4, 3. Okay, and once again, watch out for your transformations. I'm going to just do one of them. Let me do this one right here. So if you look here, this is x plus 2 squared, which means I know I'm going to shift to the left 2 units. And that minus 3 tells me I'm going to move down 3 units. And hopefully you can see how for this graph right here, if you look at the vertex, it's at -2, -3, right? And so multiple transformations, you just got to do them one at a time, right? I like to do the horizontal shifts first, and then I do the vertical shifts last. So at this point, what we're going to do is we're going to be doing an example together where we graph a function. So here we have a function in vertex form, f of x equals x minus 1 squared minus 4. So here with very little work, I know that the vertex is 1, -4. And because my vertex is at 1, -4, I know that my axis of symmetry is just x equals 1. Now to find the y-intercept, I'm going to plug in 0 for x. And again, you want to carefully plug in 0 for x. Here we're going to do order of operations, right? 0 minus 1 is really -1. You want to do what's inside the parentheses first. And then from there, you're going to do exponents next, which is -1 times -1, which is +1. And 1 minus 4 gives me -3. And so my vertex here is just 0, -3. For my concavity, because my a value is positive, keep in mind my a value in this case is just 1, right? There's the 1 in front of the parentheses when there's no number there. That tells me this is going to be concave up. And I know that when a graph is concave up, it's going to look something like this, right? Which tells me that I know that I'm going to have a minimum value right here. And if they ask you for the minimum value, it's always going to be the y-coordinate of the vertex. Right, so it'll be this. And then from there, I need 5 points. So what I'm going to do is actually, I'm going to first graph what I have. So my vertex is at 1, -4. Let me plot that here. And I know my y-intercept is at 0, -3. What I could do next is I could draw my axis of symmetry because that's going to probably give me a free point or two. Now, if you notice, I can actually take the y-intercept and reflect it over the axis of symmetry. So I do get 1 free point. And then from there, I'm going to plug in another value. So what I'm going to do is I'm going to plug in a value that's pretty close to the vertex. So I feel like x equals 3 would be a good choice. So I'm going to find f of 3. So once again, you're going to carefully plug 3 into your function. By function, I'm talking about this function right here, right, in vertex form. Once again, think order of operations. Do parentheses first, then do exponents, and then you get 0. So what I get is I get the point 3, 0. And the nice thing about this is, again, I can use that axis of symmetry. And because this point is 2 units to the right of the axis of symmetry, I can go 2 units to the left of the axis of symmetry and get another point. And you know what? We're just going to do one more point. I'm going to plug in 4 this time. Same thing as usual, right? Order of operations tells me I do parentheses first. Then I do exponent second. And if I simplify this, I get 5. So that gives me the point 4, 5. So from here, I'm going to go right 4 units, up 5. And again, using that symmetry there, if I go 3 units to the right of the axis of symmetry, I get 4, 5. If I go 3 units to the left, I'll get another point. And if you notice, this will be the graph of my parabola. So make sure you understand all of these concepts, right? How to find the vertex, the axis of symmetry, the y-intercept, the concavity, the minimum value in this case, and the 5 points, okay? So at this point, I want you to pause the video, try g of x on your own, and then when you're ready, press play. All right, so let's see how you did for g of x. Your vertex for g should be -3, +1. That tells me my axis of symmetry is x equals -3, because I know it always goes through the vertex. My y-intercept will be found by plugging in 0. If you plug in 0 carefully, you'll get something like this. And if you simplify this, you'll get -8. So my y-intercept is 0, -8. I know that this is concave down, simply because a is negative. I know that I have a maximum value, because again, if I'm concave down, I know that I'm going to have a maximum there. That maximum value will be +1. Again, keep in mind, it's always the y-coordinate of the vertex, right? Now at this point, before I come up with the 5 points, I'm going to graph what I have. So -3, 1 is my vertex. I like to always start with that. And then I know that my y-intercept is 0, -8. And I'm also going to graph my axis symmetry. So let me use another red line. Goes right through the vertex. If you notice, I get a free point because this point, the y-intercept is 3 units to the right of the axis symmetry. So if I go 3 units to the left, I get a free point. And then from there, I'm going to plug in some points. So again, when I plug in values, I want to plug in values that are close to the vertex value of -3. So I'm going to start by plugging in -2. All right, so plug in -2 in for g. All we're really doing is we're making a substitution into this equation right here, right? Sorry, we're making a substitution into this equation right here. Carefully simplify this out. You get 0. So I get the point -2, 0. So I actually found one of my x-intercepts. Knowing that my x-intercept is right here at -2, 0, I can use that symmetry again and reflect it over the axis symmetry to get my other x-intercepts. I got 2. Now let's just plot one more point here. I'm going to plug in -1. If I plug in -1, do a little bit of simplifying, you'll get -3. So I'll get the point -1, -3. And then from there, I can also reflect over the axis of symmetry. In the end, you get a graph like this. So hopefully you're able to graph this parabola in vertex form, and hopefully you can see just how that works, okay? So what's going to happen is we're going to be so we have an extra credit project, and it's going to be where you're going to be graphing quadratic functions, okay? Essentially, the idea is you can create a poster, a PowerPoint, a Google Slides, a Padlet, a Prezi, or just get 2 clean sheets of paper, preferably graph paper, and you can complete this project, okay, by graphing and calculating key characteristics. So these are the 2 functions you're going to be dealing with. The first one is in vertex form. The second one is in factored form. And what you have to make sure you do is that your poster or whatever medium you choose must contain the following for each of those functions, okay? You want the function written near the top. You want a hand-drawn graph with at least 5 points clearly plotted with all work shown. You want the vertex axis symmetry and x and y-intercept clearly drawn and labeled on each of the graphs. You also want each of these following statements. The vertex is located at, you want to make sure you show all the work for the factored form. The axis symmetry is at, again, show work for the factored form. The x-intercept of this equation are. The y-intercept of this equation is, again, show work for both. The maximum or minimum value of the quadratic function is. And lastly, the parabola is concave, up or down. Make sure you include any and all work. You will also be graded on neatness, organization, and readability. I want you to use the following rubric to guide your work and check that all requirements are met before submitting it in. And this is going to be the rubric that we are going to be using for this. And this is the rubric that we're going to be using, okay? So you can just kind of look at that and see how you're going to be graded. But essentially, you're going to be graded on finding the key characteristics with minimal error, on how you graph it with at least 5 points clearly drawn and all work shown. Make sure you do that for both types of functions, right, in each form. And you also want to make sure you write down the statements You make sure you show all your work. Make sure you label your graphs and make sure it looks nice, right? Try to make it look as nice as possible. And so this is the criteria that you'll be graded on. So this is your extra credit project. If you ever have any questions, let me know. But this is the end of today's lesson. Have a wonderful rest of your day.